So previously we draw a layout of a face body plot. Now we're gonna draw, like, find the actual body plot of the face angle. We will still use the same range, okay, since it's the same. So it's from 0 to the nearest cutoff frequency. Alright. And then you give me a while. Here is a little different. Okay, what is a little different is that since we are taking only, because if you remember, we are taking for phase angle, you're gonna have 0.2 of the cutoff frequency at the 5 times the cutoff frequency. So we will have to use the different points that is being used. So to have the range, right? So so this will be like 0.2, 0.2, and then 0.2. So you give me a while. So this 0 to 0.2 is the range from here to this first point. Alright? And then at this point, omega is equals to omega c1 is actually at this point. So what is the angle over here? Right? And then at 5 times omega c1, which is at this point, at this particular point, although I didn't draw it properly, it should be at this point. Okay, this thing should be at, maybe I just say like that lah. Okay, so this point to the next cutoff, the second cutoff frequency of the leg, okay, is this range over here. So this is why we have 5 times the first cutoff frequency of the leg, so it's 0.2, and so on and so forth. So this is why I label 5 over here. This one. So 5 times omega c2, which is this point to this point to the infinity, is actually this range over here. So these are the range that you can set up. Okay, so you need to know how to set up the range so that you can easily identify the different stuff that I'm talking about. So I believe I have explicitly identified all the points. Hopefully it is pretty clear. So let's start with the first range from 0 to 0.2. From 0, maybe let's start with the origin over here to this first cutoff frequency. Okay, this first point, okay, 0.2 of the first cutoff frequency. So at this point, the summation of this red line and this blue line, maybe I should draw a dotted line so that it's pretty much clearer. Alright, so if I were to do that, this 0 plus minus 90 degrees, you have a new line over here, right? So this is the actual body plot of this section. Okay, exactly at this point of line. Alright, and then at this particular point, okay, this is the next range already. At omega is equals to omega c1. When your frequency is at this point, okay, when you put in your frequency at this point, okay, c1 is actually minus 1. Okay, if you remember, our cutoff frequency of your lead is actually 1/10, which is 0.1. And if you were to log 0.1, you'll have minus 1 over here. So at this point, there is minus 45. There is 45 degrees and minus 90 degrees over here, right? So if I were to draw, so at this point, this 45 degrees plus minus 45 degrees, minus 90 degrees, you have minus 45 degrees, right? So somewhere at the middle. So I have a minus something like that, right? So from this point, maybe not. You give me a while. Okay, no need to give you a while. Okay, let's start from here. Okay, from here to here. Now straight away from here to here. Okay, maybe I don't need to change color lah. From here to here. Actually, from here to here, you cut to know that you're still going up, right? Because up to here is 90 degrees plus minus 90 degrees, which is 0. So you're still going up, and something like that. Okay. So this is the. Maybe I should draw it in red. It is much more clearer for you to see. So this is the actual bode plot that I'm talking about. Alright, and at this point to this point, okay, which is the range I'm talking about over here now. Okay, the second point of the first cutoff frequency, the lead cutoff frequency, 5 times. Okay, 5 times the WC1 between the frequency between this thing and this thing. This is the first portion of the cutoff frequency, the lag cutoff frequency. Alright? If you remember, the cutoff frequency can be split into two sections. Okay, one section is the before the 45 degrees, and another section is when it is 90 degrees. So this, I think you know already. Hopefully, if otherwise, you go and look back. So now currently I'm talking at this range over here. I'm talking about this range over here, right? So at this point, it is still minus 90 degrees plus 90 degrees, 90 degrees plus minus 90 degrees. So it is still at the red line over here. This is this straight line. And then now I'm talking about this point over here when omega is equals to omega C2. Okay, which is at this point over here, where it is at the actual cutoff frequency of the thing, of the lag. Okay, so it is actually 45 degrees, right? So the summation of this point, so this is 90 degrees plus this is actually what? Minus 45 degrees, and this is 90 degrees. I mean minus 90 degrees. Summation, if you add up together, you have minus 45 degrees over here, right? Minus. So this will goes down like that up till this point. Okay, sorry, up till this point, and the rest you should, calculation know that it should be going downwards, but but nonetheless you should also be careful that omega C2, okay, omega C2, the range between 5 times, okay, which is this point over here. Okay, should use different color. Which is this point. Alright, I mean should be this line, this line. The summation of them, okay, this point to the rest of the range, what is how will it goes? Okay, if you remember, now this is the trick part. Okay, if you remember your lag term has two terms, right? So lag term has two terms. What it has is that you have two angles. Okay, two angles in this case. So at this case is so the green color one, if you remember, is actually the lag. Okay, let me show you the before I draw so messy one. So this green color is actually the lag, right? This green color is actually the lag. So there is two lag angles. So this means that there will be negative 180 degrees. Okay, they are topping up each other. So at this particular line, okay, this particular line, yeah, so you have 90 degrees. Let me label. You have 90 degrees over here, right? So it's this thing over here. I mean, yeah, 90 degrees, and then the green color line is times 2 because there's 2 lag, 2 times minus 90 degrees. And then the blue integrator line, which is also minus at minus 90 degrees. Right? Therefore, what do you get? Right? So a summation of this point, the blue, so the 90 degrees plus 2 times minus 90 degrees plus minus 90 degrees. Okay, the total will be minus 180 degrees. Right? So at this point of time, we're gonna have a minus 180 degrees. Okay, which is somewhere down there. Okay, so I'm gonna extend this graph to minus 180 degrees. Right? So just now you may say that, so this is the point. So you may wonder, at this point, this is minus this is 45 degrees. Why suddenly come here? Because I calculated wrongly. This shouldn't be 45 degrees. It should be 90 degrees. Okay. So at this point, this point dude over here should be 90 degrees. Alright. So I'll have a new. Okay, I should redraw. Let me okay. So maybe at this point this is 180 degrees. Okay, 180 degrees. So at this point, it shouldn't be. I should be talking about this point, 90 degrees. Okay, because that's how I calculated wrongly, so sorry, my fault. And then like that, and then the rest is gonna go all the way down. Yeah. Okay, not all the way down, bitch. What am I doing? It should be 180 degrees. Why? Okay, so far I've been talking another language. Okay, to this range, okay, from omega c2, okay, 5 times omega c2, okay, which is at this particular point, this range, okay, from this range onwards, okay, the overall add up is always this phenomenon over here, 90 degrees plus the minus 90 degrees of the integrator, okay, the integrator is minus 90 degrees, plus the two lagging terms minus 180 degrees. So the rest would always be minus 180 degrees. But just now I calculated wrongly 45 degrees. It should be minus 90 degrees also from here. At this point, okay, at this point, at this range, if you were to head back, okay, at this range, it shouldn't be minus 45 degrees. It should be minus 90 because there is two terms of the lag forgot. So it should be like that. Right, so if you were to clear up a little bit, I should have this graph over here. So this is the bode plot for your phase angle. Alright, so next video I'll talk about how to calculate the phase margin, okay, and the exact value of the thing, just like the gain thing. Hopefully this video helps. See you.